This video is about why builders actually shipping in 2026 don't talk about prompting. They talk about their skill library. Vibe coding peaked. The engineers pulling away from the pack aren't writing better prompts. They're building infrastructure around the model. Scale markdown files that encode their standards, their stacks, their workflows, and every session gets smarter. The GitHub repo by obra superpowers hit 188,000 stars. Its core behavior? The agent never writes a single line of code until it pulls a spec and gets sign off. So that's not a prompt, that's a discipline. And it is the reason some engineers are shipping and others are still debugging hallucinated APIs. Here's what's wild. 18 AI agents now run the same open standard. Claude, Cursor, Copilot, Gemini CLI, Codex. The skills library you build works everywhere. The engineers building it now are building a moat. Let me back up for a second, because I want to make sure that you actually understand what we're talking about here. Because most people heard SKILL.md and just scroll past it. They think it's another config file. It's not. When you spin up Claude Code or Cursor and start a session, that AI agent has zero memory of everything you've learned the hard way. Every convention you follow. Every tech stack decision you've made, the way you structure your components, your error handling, your database schema patterns, gone every single time. You're back to square one, and the agent is guessing. The prompting reflects. The one most developers have is to write a big system prompt and hope it sticks. Be a senior engineer. Use Next.js. Follow these patterns. That's what you tell the AI. And for a while, that works okay. Until the context window fills up. Until the agent hallucinates a library version. Until you're 2 hours into a debugging session because the model didn't know your Supabase auth setup and invented its own. That's the prompting ceiling. You hit it, and you don't know why it happened. And you just assume that the model isn't good enough yet. It's not the model, it's the architecture. A skill.md file is a markdown file that lives on your project or in your global skills directory. It's not a system prompt. It's engineering context written to be consumed by the agent at the start of every session. Your conventions, your stack specifications, your decision criteria. The agent reads it before it does anything. Now, it's not a brilliant generalist who just arrives on day one. It's a senior engineer who's been on your team for 6 months. The difference in output quality is not subtle. I'm going to show you exactly what that looks like in a few minutes. But first, I need you to understand why this became a movement and why it became a movement fast. Now, the question I had when I first heard about this was, okay, is this just a working theory thing, or did someone actually prove it at scale? Because it's easy to make a compelling markdown file for your own little project. What I wanted to see was real engineering culture packaged as skills library. 2 repos answered this question for me. One from an indie builder, and then one from a Google builder. Let's start with obra superpowers. A GitHub repo with 188,000 stars. That number is not a meme. That's engineers voting with their attention at the level most frameworks never reach. And when you actually dig into what superpowers does, it's deceptively simple. The entire behavior of the system comes down to one core constraint. The agent never writes a single line of code until it has a spec and has gotten sign off on that spec from the developer, you and I. Let me say it again, because it sounds obvious until you realize almost nobody does it. The agent doesn't write code until it understands what we're building, writes a spec, shows you the spec, and you approve it. Every session starts with alignment, not assumption. What Obra figured out is that the root cause of most AI coding failure isn't the model quality. It's context ambiguity. The model makes a decision, usually a reasonable one, but it's not the decision you would have made yourself. And now you have 300 lines of code built on wrong assumptions. And you're either going to spend an hour unwinding it, or you're going to keep building on top of a bad foundation. Superpowers closes that gap before the first line of code is written. That's not a prompt, that's pure discipline. Now, the second repo is different in character, but equally important. Addy Osmani, Agent Skills. Addy Osmani is the engineering director on Google Chrome. And what he did, what I think will look in retrospect like one of the most significant open source projects of 2026. It takes Google Chrome's internal engineering culture and then packages it as a skill.md file. Not a blog post, not a style guide, not a README, skill.md files, designed to be loaded by a coding agent as engineering constraints. Hiram's law, the principle that all observable behaviors of a system will be depended upon, so backwards compatibility is non-negotiable. The Beyonce rule, if you like it, you should have put a test on it. Packaged as agent context. Google's accessibility standards, their performance budget rules, their component architecture decisions, all of it installable. Really think about what this means. An engineering standard that took years to develop inside one of the most respected browser engineering teams on the planet. It's now something any developer can drop into their skills and run it. The agent doesn't know your stack anymore. It knows how Google thinks about software. And here's where it connects back to the first point. These aren't prompt templates. They are constraints. The agent operates inside of them. The difference is precision. A prompt suggests. A skill constrains. This is the part of the story most people miss, because they're focused on their tools of choice. I use Cursor, so this is a Cursor thing. I use Claude Code, so this is a Claude Code thing. Wrong. Skill.md is not a proprietary format. It is a de facto open standard, and right now we have 18 AI agents supporting it. You can use Claude Code, Cursor, Gemini CLI, Windsurf, OpenCode, GitHub Copilot, and others. The list keeps growing. The skill library you build today, your dev stack, your architecture patterns, your project conventions work across all of them. Think about your current dev setup. If you switched AI tools tomorrow, Claude Code to Codex, how much of your workflow would you have to actually rebuild from scratch? With skills libraries, the answer is basically nothing. This is what a moat looks like in the AI era. It's not which model you're using. Models change. ChatGPT 5, Claude 4, Gemini 3. The frontier keeps moving. Your moat is the institutional knowledge you've encoded into every skills library. Every decision you've made, every mistake you've learned from, every pattern you've refined, that's your edge, and it's portable. There's a concept from software engineering that applies here in a way I think is worth naming explicitly. Hiram's law states that with a sufficient number of users and an API, it doesn't matter what you promise in the contract. All observable behaviors of the system will be depended on. In human terms, the longer you use a system, the more implicit knowledge accumulates around it. Most of that knowledge lives in developers' heads. It never gets documented. A skills library changes that. Every piece of implicit knowledge, the way that you handle auth, the way that you structure API routes, the pattern you never want to see again, becomes explicit. The agent knows it. The next developer you bring on can read it. The institutional knowledge stops dying when the context window closes. This is why Obra's spec-first discipline and Osmani's Google patterns aren't just clever productivity hacks. They're a new engineering philosophy. The question isn't, how good is my AI coding tool? The question is, how much do my agents know about how I build? All right, I want to show you what this actually looks like in my setup. Because theory is nice, but I'm a builder, and builders show receipts. So let me pull up my skill directory. Right now, I have 20 custom skills in production. These aren't demo files. These are skills I use every day. Let me walk you through the cluster. The first cluster is DevStack. I have Next.js 15, which has 82 reference files organized all under the SKILL.md file. The SKILL.md file is just an orchestration layer. Every routing convention, every server component pattern, every caching decision I've made, codified. When I open a new project in Claude Code, the agent knows my stack before I type a single message. I have a Supabase, Stripe, and Vercel skills that sit alongside with the Next.js skill. Every time I write up auth, the agent already knows my RLS policy patterns. It knows which Stripe webhook events I actually handle. It knows my Vercel environment setup. The second cluster is my YouTube production pipeline. This is where things get a little different from what most developers are building. I have a research agent skill, a hook and intro skill, a script skill, an SEO agent, a visual director. I have a short specialist. The entire pipeline runs on skills. When I sit down to make a video, I'm not prompting from scratch. I have my framework already written into these skills. I'm running repeatable production system. Every skill knows its role, knows my voice, knows the brand constraints. The output quality is consistent in the way that prompting would never give you. The third thing that I want to show you, and this is the piece that I think that most people don't build, is the cross-referencing. So my script agent references the brand manager skill. My title and thumbnail agent reference the hook and intro agent. Skills can be dependent on other skills. You're not building isolated prompts, you're building an automated system. The whole thing took time to build. I'm not going to pretend it didn't. But here's the math. I built it once, and now every project, every video session runs faster, produces better output, and requires less prompting overhead than anything I was doing 6 months ago. That compounds. The work you put in today keeps paying out. So here's how you actually start, because this is the part where most people freeze. They don't understand the concept. They see the value, and then they open a blank file and don't know what to put in it. Don't start with your whole stack. Start with your highest friction surface, your bottleneck. The thing you prompt about the most. The thing where the agent keeps getting it wrong. That's where skills pay off the fastest. For most developers, that's one of three things: authentication logic, component architecture, or database schema conventions. Pick one, open a skill.md file, and then write down every decision you've already made about that surface. Not theory, actual decisions. We use JWT to store in HTTP-only cookies, not local storage. All server components live in \app. Client components are co-located in \components. Foreign keys, always use UUID, never integer. That's the level of specificity that you want. The agent doesn't need inspiration, it needs constraints. Pause the video right now, open a new file on your machine. Call it SKILL.md. Write the top 5 decisions that you've already made about your current project that you've never documented. Just 5. You'll have a skill in 10 minutes. Once you have your first skill, the framework is the same for everything you add. What does the agent need to know? What decisions already have been made? What should never happen? The last one is important. Negative constraints are valuable as positive ones. Never use useState for server data. Never skip the spec step. Never ship without an RLS policy. The agent operating inside negative constraint is the agent that stops wasting your time. And the last thing, publish it. Not for clout, because the ecosystem compounds when builders share their skills. The reason Osmani's repo hit that star count so fast is because every developer who looked at it thought, that's my problem too. Your next JS skill might be the one that someone else needs. Your production stripe patterns might save another builder's 3 days of debugging. The frontier isn't a solo game. The builders building in public, sharing their stacks, publishing their skills, those are the engineers who end up building the standard. If you want the actual skills, my full library is on GitHub. The SaaS dev stack, the YouTube production pipeline, the cross-function referencing structure for Obsidian. All of it is there. Rip out whatever you need, build on top of it. Link will be in the description. If you've been wondering why you still can't ship a production despite using AI every day, watch You Use SaaS Every Day, You Can't Build One. That's the builder mindset piece that sits underneath everything we talked about here. And if you want to see the actual skill idea, watch I Don't Prompt Claude Anymore, which is the earlier video where I broke down why I stopped prompting and started building infrastructure. Both are linked in the description. The prompting era didn't last. The infrastructure era is here. The engineers building their skill library right now, this week, are building a moat that gets wider every session. The ones still prompting from scratch are starting over every time. You know which one you want to be. Stay hungry, keep building.